In our Data Masterclass podcast, data leaders share their unique stories. In this episode, we talk to Data Quality Camp Chief Operator Chad Sanderson, who before worked as Head of Product of Data Platform at Convoy. We talked about the rising role of data contracts in modern data management. Let us welcome your host, Alex Borek.
Hello, my data friends. I have a huge pleasure to have Chad Sanderson today as a guest at the Data Masterclass podcast. And Chad is the head of product of data platform at Convoy. And he will explain a bit in a minute what Convoy is about. And one reason why I'm very, very excited to talk with Chad is that he wrote tons of really in-depth and exciting articles on the topic of data products, data contracts, and really rethinking data management into something that actually can work. And I found those articles very inspiring. That's why I reached out to Chad, and I'm really glad that he's here with us. Welcome to the show, Chad.
Yeah, thank you for having me.
So, Chad, give us a bit of a glimpse of your role. You know, what's your current role at Convoy?
Yeah, so I ended up leaving Convoy back in November of 2022, but I was there for over 3 years. And when I was there, my job was to essentially manage their data platform and data science platform team. And what that basically looked like was I was responsible for the data engineering team and a set of software engineers that were building internal data quality and data science platforms. Like we had an experimentation platform, we had an internal feature store, a metrics repository. We were responsible for all the tooling that sat on top of our data warehouse. So we managed Snowflake, Fivetran, Debezium. At one point we were managing Kafka, but then we shifted that over to another team. DBT, Airflow, and so on and so forth. I was also responsible for setting the strategy and the direction of new investments for the data platform team. Like, what are the things that we should go and build? How do we know if the things that we have built are working? How do we prioritize the investments that we're going to make next? So that was my main responsibility.
Wow. So that was quite a good breadth of topics you had to take care of. What shaped you there? You made a lot of experiences that then prompted you to write a lot of articles. What were the things, that really struck you?
Yeah, so I joined Convoy from Microsoft, and at Microsoft, we were working on another centralized infrastructure team that the biggest issue we had was a compute optimization problem. Microsoft had massive amounts of data, as you can probably imagine, especially some of the larger internal companies at Microsoft, like Bing or Windows or Microsoft Office, right? Just huge volumes of users. And so anytime those teams wanted to do A/B tests or deploy machine learning models, they had to wrangle with this very old legacy, crufty infrastructure that was established back in like 2008 or 2010. And it was very expensive. And so it was, like I mentioned, it was mainly a cost optimization problem. But when I got to Convoy, the data volumes were far lower, on the order of billions of rows. And it kind of made sense because Convoy is a B2B marketplace, a two-sided B2B marketplace. So on one side, we have shippers that are trying to move some freight from one place to another place. And then on the other side, we have trucking companies, basically. And so we only had around 1,000 shippers in the marketplace and around 50,000 truckers. So as you can imagine, there just weren't nearly as many users and they weren't performing nearly as many actions. But data was still very important to Convoy. Our primary differentiator as a company was our machine learning models. And those machine learning models would sit on top of our marketplace and they would make pricing decisions. They would predict the ETAs of shipments, when they were going to arrive, whether they were going to be late or not, how much detention would they accrue, which basically means if they arrived at a facility and they couldn't unload, they would get paid an extra amount for every additional hour that they waited, right? All these things were very important to Convoy. So very small amounts of data, but machine learning and the applications of data were massive. And unfortunately, the way that our teams worked together to achieve those ideal outcomes was not very good. We had huge scalability problems. We had lots of just relationship issues, I guess you could say, between data engineers and data scientists and data producers. Like no one was really getting along. Stuff would break and people would get angry and start yelling like, hey, why did this thing happen? And that was a different sort of challenge than what I was used to. And I tried to take a very first principles approach to that. And instead of just assuming, well, I guess this is the way of the world, right? There's just going to be infinite conflict as the data engineer. I didn't accept that. And so the 3 years that I was there was basically me trying to build solutions for a lot of those perceived cultural problems.
I love that statement that you did not accept it. Because I see so many data leaders that just take it as a rule of life. That, it must be this way. It always has been this way, but it doesn't. And I think that's so important to believe that there is a way to solve things. And I think that gave you a lot of boost in your creativity later on.
And a big part of it was I looked at the relationships between other technical groups in the company, or even non-technical groups, honestly, like product managers and software engineers had a pretty good relationship and they coordinated through tools like Jira, and that made everybody's life a lot easier. Software engineer, like backend engineers and front engineers had pretty good relationships and they would coordinate through GitHub, and they had version control and they communicated through PRs. And UX designers and software engineers had systems, like they would use things like Figma and they would sort of design. I don't know if you've ever used Figma, but it's basically like a sort of UX design platform. And
Yes.
One of the cool things that Figma does is once you create the designs through, you build your boxes or whatever it is that you do, it automatically translates that into
code.
It creates the code, it creates the CSS. And so I was just looking at all of these sort of systems that were in place to facilitate great relationships between, some group and software engineers. And I felt that was totally missing in data. There was nothing like that. And that if those systems did existed, whether it was technology and product or just culture and process, that it would make things way better. And it seemed like there was a precedent of these problems being solved.
Wow, yeah. I fully agree with the statements, and it's a very interesting way how you put it. I think I have not heard it, the way you describe it, I think it's very accurate and to the point. And I think we're missing that brutal analysis of the situation sometimes in the data space. And you left Convoy, and I saw that you also worked for venture. Did you advise a venture capitalist for a while? A very famous one, actually.
That's right. So I do some scouting for a VC firm called Sequoia, which was kind of like a happenstance thing, to be totally honest with you. I started getting involved in startups really when I started my journey at Convoy. It was about 3 years ago. I didn't realize this at the time, but once I started managing the data platform team, I was responsible for making the purchases of data tooling as well. So, we eventually bought Tecton for our machine learning feature store. We bought a company, we bought a product called Stemma, which was a hosted version of Amundsen, the data cataloging tool. There's a few other products that we bought as well. And because I was the sign-off decision for that, it meant that a lot of early stage data and ML and infrastructure companies all wanted to talk to me because Convoy was basically in the exact market that a lot of these companies were selling to, right? They were early enough that they didn't have these very long, heavy procurement processes, but they were late enough that they were still willing to pay, 40, 50, 100, 200K for a really good product that solved the problem. And I was sort of this customer target. And because of that, I did end up working with some of these companies. These companies said like, hey, you're partnering with us to help us design and sort of build this thing out. Could you please go speak to a few venture capitalists and just make the case that like, hey, a feature store is important, or experimentation on top of the data warehouse is important, or data quality is important, or whatever. And I would go and do that. And the VCs would say, wow, I really like your worldview, like the way that all of this kind of comes together. And you can kind of explain like why this is really important and why this is the direction that that sort of data infrastructure is going in. Can we meet more regularly? The thing is, a lot of these VCs, they're not practitioners anymore. A lot of them used to be, like 5 or 10 years ago or something, but now they just do investment deals. And so the way that they learn about what they should or should not invest in is by talking to practitioners like me and asking them like, hey, is this a real problem? I saw a company that like looked like this. Like, is this an issue that you had? What do you see is on the horizon? What should I keep my eye out for? So I kind of became a resource to them in that way. By the way, if there's anyone who is listening to this that is in a similar position as I am, and you want to get involved in like VCs, like it's a really easy to do that. Like it's very, very simple. And eventually I came across the Sequoia team just by like my name kind of being spread around. And I worked with them for about 2 years. And then they said, hey, we'd love to invite you to participate in the next class of Sequoia Scouts, which is I basically do investing in companies on behalf of the firm.
Oh, that sounds like a very amazing job to do. It's very exciting because you're on the forefront. You see what's coming. So what is coming?
Yeah, it's a good question. So I think there's a few really interesting things that all kind of seem to be happening very quickly. At different stages of the pipeline. So I've sort of been seeing products at basically three different stages, right? There's kind of upstream, midstream, and downstream. And upstream is everything kind of like pre-data warehouse. And I think that there's going to be a set of new platforms and systems that are all about doing data management shifting left, right? Which is one of the main things that I talk about. And so that's kind of what I'm most interested in, but that's like upstream ownership of contracts, upstream modeling, even doing like upstream sort of design of the data model downstream, and like how do all the databases kind of come together to form a very coherent logical model and physical model. I think we're going to start seeing a lot more of that as data becomes treated closer to a product. So it's like APIs and versioning and CI/CD and better change management and better change communication. I think we're going to start seeing a lot more of that. In the midstream space, so these are like tools for data developers to better do their work. I think there's a really big shift towards streaming, and streaming becoming more of the de facto, data movement system than batch, and just making it very, very easy and simple and low cost to do that. There's interesting tools. I don't know if you've seen SQL Mesh, but there's sort of DBT competitors that are starting to come out now that look very interesting, that are just like adding more governance, more, better access control, better like true sort of data modeling capabilities in the IDE. It just like, not just, oh, hey, here's a CLI to write some SQL. Like it's more of a richer experience for the data professional. And then downstream, so those are, I would say those are more like data quality tools like Monte Carlo that do like monitoring on aggregated data, dashboarding tools, of course. I think what's getting really big there is sort of the whole ChatGPT stuff. So this is like folks who now want to, you've got a whole bunch of dashboards. We're going to put ChatGPT on top of all of those. And all you have to do is go and type in and say, hey, I'm looking for, customer revenue or something like that. And it finds what is the most used dashboard that like best aligns to what you're looking for, like those types of platforms. So yeah, pretty interesting stuff.
Well, and I guess, at the end, when you put such technologies on top, you will struggle with the same things as before. Like, the dashboard is great if the data is great, if the metrics are the right ones, if you know which are the right ones. We have millions of metrics. Which ones are the right ones? If it's hard to see for you, even if you invest time and look at those dashboards as a human, it will be also hard for the machine. Maybe machines become better at it over time. But I think there is a lot of foundations that we need to create. And I really love how you described, the problems that we face today in data management. and also, the typical data journeys that you described in a company, in any company, over time, leading to data collaboration problems, as you put it. Could you describe that a bit? What are the problems that you see, and what kind of journey do companies take?
Yeah. So I think there's a few really big problems, and some of these problems stem from the way companies are developed these days, like how they evolve. One of which is we've just made this big transition to software, right? Like software first. And that didn't always used to be the case. In the 70s and 80s, companies didn't have apps, but they did have data. And that's changed now. And so what that essentially has meant is, as we've moved into the cloud and we've decoupled storage and compute, and now it's very cheap to create a data lake, and it's very easy to just throw a whole bunch of data from a microservice into the lake and then port it over into Snowflake or Redshift or Databricks or whatever it is that you're using. We've kind of seen a, decomposition of the data architect. There's no one that's doing the planning anymore. They're not thinking about, well, what's the data that we need and how should it be organized? And are we getting the right data from these microservices? And can we ensure that software engineers are making the right decisions? And are people following all the right constraints? And are we creating this really great environment that people can use without making bad decisions? Like, that's kind of gone in a lot of cases. And so the result, go ahead, please.
No, and just to add one thing, and the people that we thought will take care of that in such a model struggle with that, So what I find is that you have usually these principal engineers, or however you call them, like lead architects in our company, and at Zalando we call them principal engineers, that have this kind of architecture type of role. Like, they are basically engineers that are on a leadership position but are not managing engineers. But usually those come from heavily software-based backgrounds, right, and they struggle to do the right thing when it comes to data. Do you observe that as well?
100% I observe that. And I honestly think it's almost like expecting a engineering team to make the right choices for a UX design team. Like, I think that these are very different types of organizations, and the concerns you have as a principal software engineer are going to be very different from the concerns you have as a principal data engineer. I was mentioning this morning, but when you look at how the purpose of a microservice, right? Like, the purpose is to enable software engineers to move very quickly, to be flexible, to be iterative. And there's a reason for that, right? Because if you're shipping features, you don't actually know how much value any feature is going to have until you've deployed it. That's the whole point, right? And so therefore you try to deploy as much as you can, so that then you can figure out what works and you can iterate. And if something breaks and it's not actually solving a problem, that's totally fine. You can roll it back. It's no big deal. And so you need to be as decoupled as possible in order to do that process effectively. But in data, that's really not what we care about, right? Like, the sort of primary function of data is to be correct, right? If the data is wrong, then anything else that you want to do with it, any analysis, any machine learning, all of that is now, tainted. We do need like some concept of a monolith. Maybe we don't need the monolith everywhere, but there does have to be some source of truth that we can look at some data and say, you know what, we trust this, we can take a dependency on it, we can rely on it, we know exactly what it means, and we know how to use it. And if principal engineers are not thinking that way about the data, then they're going to make suboptimal choices for like the downstream teams.
And this is exactly what I have been observing in tech companies, not in traditional companies. I think in traditional companies you still have data architects, and everything tends to be, a bit more traditional. Let's put it this way. But in tech companies, I have seen exactly that happening, that you treated data almost like software, where more was better. And you try to ship more data sets. You want to create more data pipelines until, your whole sort of data pipelines, when you look from the space, it looks like a jungle. It looks like New York, in the early 20s, when you had these cables flying around, and And I think all of us, or most of the tech companies these days, come to the realization that that is not optimal. You need to change the paradigm from let's ship more data pipelines to let's ship the right data pipelines. Let's make them more reusable rather than just adding another pipeline, like in New York in the early 20s, where you just add another line because you need to fix that problem because, and at some point these things break. And I think we have that scalability issue at some point in the journey, like you put it also in your articles.
Exactly. Well, and here's the thing that I think is, I feel teams often take the wrong approach. Software engineering and data engineering are kind of looked at as almost the same thing, just applied to different use cases, and that's not how it is, right? There's actually really big differences between data and software that are super important to think about, in the same way that there's big differences between design and software, right? So like design, just as an example, UX design. UX design does require a set of centralized components, because you don't want, if you're building a new feature in an app, then you don't want to use like a drop-down menu that's not used anywhere else in your application. Like, it's just going to look weird, and someone might not know how to interact with it if they've interacted with the same type of drop-down menu in 7 different places and not this one. You want to use the same colors for consistency. You want to have the same effects when you click on a button. So you need to have a library of components that gets reused. But the actual designs themselves, the screens themselves, they don't need to be reused, right? You can have an individual UX designer working in this isolated environment, designing screens using reusable components, right? That is a unique structure to design, and it's different from the structure in software engineering. And data also has a different structure, right? And in data, like, when I've even heard people use this phrase before, decoupled data products. And to me, I'm just like, what does that even mean? How could you possibly have a decoupled data product? Like, to me, a decoupled data product would mean, like, I, the data engineer, am, adding telemetry to the application. I'm creating the logs, and then I'm now, I own the ETL, and I'm constructing the views on top of those. That to me is truly decoupled. Like, I own everything. But that's like not actually how it is, right? Like, you have teams, service teams who are generating data. I have to take a dependency on them. I transform the data, and maybe I have to take a dependency on many teams. And some of those teams might be data scientists, some of them might be data engineers, some of them might be analysts, some of them might be software engineers. But the data product, the valuable data asset that I produce, it has to be tightly coupled to all of those upstream sources. So to move to a system that, like, by design does not support tight coupling, it doesn't work for data. The other big problem is that data use cases almost always come after the software engineering use cases. So if you're building applications, you need to push a feature, and then once the feature exists, now you can think about how you want to analyze it. Or now you can think about, we're going to do some experimentation and figure out if there's anything interesting here we can put into a machine learning model or something like that.
And so that makes data always an afterthought. And that's part of the problem description, because sometimes you need to proactively design, how you design software in a way that it actually fits the data, or that it doesn't destroy your data in your company.
You're exactly right. But the problem is, now you have to balance this, like, the objective fact. And the objective fact is, we cannot have any interesting insights or any operational use cases of data without the feature, right? That's the truth. And you also have to balance that with that the application engineers are typically not incentivized to go slow, right? They are incentivized to go as fast and ship as quickly as possible, to be iterative. And so at least the world that I lived in at Convoy, is, if I ever tried to slow down the engineers from shipping features so that they could build a better data model, that's just not happening, right? And I think that this is what most of us kind of experience operating in the, like, tech world. And so the question is, how do we continue to live as best as possible in this universe if we know more than likely they're not going to do the data modeling that benefits us in advance, and they're not going to do the data architecture in advance? That means whatever system has to whatever system exists has to like exist within the constraints of the universe that we live, right? And so that's kind of where a lot of my thinking has taken me.
So you described the problems we have with data modeling in general today. Is there anything else, that you would add to your problem statement, that is crucial to understand?
I would. I think that data evolves with the business in a way that software really doesn't, right? Like software can be truly siloed. Like if I have an application and that application it allows a customer to sign up for a website and then to go and buy products on that website. That's great. And I probably have one service that handles the sign up process, and I have one service that handles like the payment process. And I have another service that handles like something else. And so if the payment process changes, that's fine. The sign up process is not affected by that. But in data, all of these things are kind of inexorably tied together. If the business decides, hey, we're going to offer a different set of products, or we're going to change how we do pricing, everyone that has taken a dependency on the old model is now going to have to update to the new model in a way that, the old sort of the decoupled applications, they don't have to think about that in the same way that we do. And the business is always evolving, and it's evolving from both sides. It's evolving from the technology side. The services are always changing. So maybe we decide to decomposition a microservice. Maybe we decide to add more. We decide to add new features, but it's also changing from the business side as well. We're changing what products to stock. We're changing like, how we charge tax. We're changing billing. Like all these things are also changing. And so data is sort of caught in the middle, and it has to be able to be responsive bidirectionally. And I think that's another problem.
And it sometimes feels, or maybe always feels, like it's squeezed because of that in between, because you have those pressures coming from tech, and all the changes come from tech, and then all the changes come from the business. And with some parts of data, in particular when it comes to the core data, having the problem that it needs to be fairly stable, because otherwise it creates a lot of problems. And it's almost like a natural dilemma. It's a recipe for
disaster.
For disaster,
and there's one more problem that I want to mention, because you reminded me of this, is like this idea of sort of core data models, right? Like core entities that are very important to the business. I find that there is like as an entity becomes more important to the company, it actually, there's an inverse relationship in how challenging it is to define ownership for that entity. So if I've got this, let's say I'm Netflix, for example, I would bet $1 million that the concept of customer does not have one owner, right? Like that data is probably coming from a monolith. It's probably coming from microservices. There's probably customer data being picked up in a variety of different features. Like I would guess like no one actually has a single comprehensive definition of what does a customer mean at Netflix. And some of that is just because it's a result of tech debt and the way that their architecture is built and the way that the product is built. But some of it is also just because like these definitions change over time. And it's very hard to for every single team who has their definition of customer to contribute it back to the whole. But if you're working with a very localized domain, like something that's very small and iterative that only your team cares about, okay, well then ownership is actually quite simple. And again, this is something that makes data management incredibly hard, especially at tech companies. And even concepts like data mesh, right? Like one of the core, conceptually, I love data mesh. I think it's such a smart idea. Practically, data mesh seems very challenging to implement, and I've tried doing it, and that's a whole other conversation to talk about. But like, one of the core entities at Convoy was shipments and shippers. And no one owned that. There wasn't a single service that produced that data. It was coming from many different services. And in some cases, it was coming from the monolith. How do you create ownership over something like that? I think that's also quite challenging as well.
It is. And I think, my experience with data mesh is that I have seen nobody in the world so far. Maybe there are people, but it's just my limited knowledge is that nobody has implemented data mesh by the book, so by the Zermatt book. I think everyone has their own versions because you have all these things, like the data mesh book is like the theory. It's the almost like the never land of data. Okay, this is how it could work. Right. But when you put that into practice, you will find a lot of things that need to be adapted to fit your environment, but maybe also to fit reality, to be honest, between us. And I think one of them is really, and by the way, I love the book and I love the concepts, and we use it. We use a lot of these concepts, but I think everyone needs to think through how to solve some of these problems. And one of these is how to manage what in old data language was called master data, maybe also, partially in tech companies, but in tech companies, this is a concept almost forgotten. While in traditional companies, that's the usual part of life. Like you usually have a master data management team that then works out with the different owners of the different pieces of the overall definitions. And they need to work constantly to create that overall sort of definition of what a customer is, what a product is, and so on. Right. And I think, that's something that I think is tough to do, but it's possible also to do in tech companies. We're doing that. It's just that it requires synchronization of several owners, so everyone owns a piece of that, and then you need to bring that puzzle together. I think that's the only way that I've seen to create such federated records that need to be single source of truth.
I agree with you. Probably where my head is at with a lot of these things is my personal opinion is I think it is very unlikely, maybe in the age of AI, right? Maybe AI is going to be the thing that actually causes these businesses to totally change their organizational model. And now we move to data domains after 40 years of not doing that. But what I feel is probably more likely is that ownership of data is going to be radically more incremental. And it will start off as just saying, hey, we own this database, and there is a column in this database that's really, really important to someone downstream of us. And they need it to never be null. And that's something that I can do, right? I can ensure that a single column is never null. And I think honestly, if we're also just being honest with ourselves, I know kind of like this is something that all data people do, including me, to be honest with you, is like we sort of think of the grand design for solving every problem in the world, right? Because like we kind of know what the ideal data system looks like for us. And like I said, I certainly am very guilty of that. But if we're being honest and we're sort of asking, like, if we follow the Pareto principle here and say what is the 20% of the work that is going to solve 80% of the problem, and we asked our data consumers, so the people who relied on us and who use this data, what their biggest problem was, I would probably guess the problem is like 80%. I just don't want things to change unexpectedly. I would say that that's like 80% of the issue. Like I've created my dashboard. What I don't want is for the CEO to send me a Slack message at 5 p.m. and say, why do these numbers look wrong? Like that's the thing. That's like the terrifying thing is I don't want things to change. I don't want to be broken. And if something is going to change, I want to know about it and I want to be able to plan for it. Like I think if that issue was solved, I think 80 to 90% of the problems go away, or at least the complaints go away.
I think you're right that this is the number one issue because it creates the biggest pain. I mean, it's sort of like you said, like the nightmare for any data engineering team. And I'm managing a couple of teams that provide some of the key data sets to the rest of the company, and for them it's really the nightmare if something is changing and then suddenly things break and then everyone downstream is complaining. Like you don't want to be in that situation, and you are in this situation very often. But at the same time, I think another big problem is really to understand which data to use.
That's true.
It's a big problem.
I would say I agree with you. I would actually put that I would probably amend my statement and say those are probably the two. I would probably say, like, if those two were solved, you know what it kind of reminds me of? It sort of reminds me of the relationship between version control and CI/CD and Agile, right? And Agile is sort of this worldview, this ideal worldview of like, oh, well, this is how we can develop software in this incredibly iterative way, and it all has beautiful documentation, and there's a whole manifesto, and it lays out everything that needs to be done in order for that to happen. When really, like, 90% of the problem, I think, is solved by versioning and having some type of, deployment process, like some type of controlled deployment process and integration process. And like, if you have those two things, 80% of that issue is solved. Is there still some other stuff that you can certainly do to like incrementally just make better and better experiences for software engineers and product teams? Like, yes, absolutely true. And I think that sort of what you're saying, at least that's kind of how I'm interpreting, is like, that's kind of like the relationship of what we're talking about now in data mesh. Is like, if you solve the problem of like, I don't know what the heck this thing is, like, I want to be able to find some information, trust what it is, and know it's not going to break. That's like, that gets us 80% of the way there. And then the rest is like, let's incrementally improve this system over time. And we'll probably like get close enough that it's now a workable, like life. People don't go home and want to quit their job every day.
So I think that is already very good advice, and I feel guilty as well. I think we should keep things more simple, and we live in a very complex environment, as you described in your problem statements before. But at the same time, our solutions need to tackle one thing at a time, and not try to solve everything at once. It's impossible. It's basically impossible. So you have to take the biggest problem and first, and handle and find first solutions, of create improvements. Let's put it this way: create tangible improvements on those. And I'm wondering, if the data contract concept or the data contract sort of, what is it actually? Is that a paradigm? Is that a way of thinking in data management? If that is something that can actually help here, because I saw you were writing a lot about data contracts, and you were advocating that it's part of the solution conceptually, or to many of the problems and challenges we have today.
Yeah. So the way that I see, there's a few things here, right, that I think is important to define first. Like, I think one of the reasons that software engineering doesn't seem to have a lot of the change management and communication problems that data teams do is because there is an object over which you can iterate. And design teams have the same thing, right? And for the software engineering teams, this is the PR, right? Or rather the code base, right? You've got this code base, and the way that you iterate it over that code base is through pull requests. And each pull request says like, hey, this is the thing that has changed. This is sort of the context of that change. And all the people who care about this thing changing are able to be in the loop. They sort of have a human in the loop review, and they can say, yep, everything makes sense. There's nothing here that's going to negatively impact me. Let's go ahead and roll this out. And then there's sort of this secondary gate, which is CI/CD, that says like, okay, now that it's sort of past the human in the loop review, now we're going to actually make sure that things are like integrated in a healthy way and nothing sort of fails there.
Right.
And I think that is the piece that's needed for data, but that can't just happen. It's for data, it's not about just happening at the deployment level. It's about the entire pipeline, right? So it's not just a single PR. It's not like a single change to a database or a single change to, a table or a data model in DBT or something like that. It's about the whole system. Because if something changes in a database, like let's say we drop a column or we change some business logic, the real problem with that is that you're potentially impacting whatever data product sits at the very end of that pipeline. And like, those people are really going to care. And so the question is, how do you do change management and change communication when, number one, your producer and consumer have like very fundamentally different roles and they speak different languages, like quite literally. And so this is kind of the purpose of the data contract. The data contract is the object that is iterated over. And so it essentially defines like what is this data? What do we expect it to be? What are the semantics of the data? Do we expect schema consistency? What are the data types? And so on and so forth. And anytime that contract is changed, now you have a review process that can be kicked off with the right people who are dependent on that data to look a certain way, right? And now you're not reviewing changes in JavaScript or TypeScript or whatever language it is that someone is working with, which means nothing to an analyst that speaks SQL, right? But if the contract changes and you're saying, oh, there's now some column that is called first name, last name, and that's being renamed it's being split into two columns, one first name, one last name. Well, I understand that change. I understand how that's going to affect me. And so I can now advocate for myself. That's sort of the core of what the data contract is. The second component. Oh, sorry. Yeah.
And do I get it right that it's actually more about transparency that something will break rather than preventing it from breaking and giving me the time to react? Because, with contract, you could also think about basically really a contract where, me as the data producer, let's say of customer checkout events, I have to talk to hundreds of different consumers before I change anything, which would, of course, not work in practice. But what you're saying is I just need to be aware of who am I breaking and let them know so they can, and give them maybe time to raise their hand and raise their voice if it's really critical.
That's right. And partially right. So I think that ultimately it should be up to the business to decide what happens with any change. So for instance, at Convoy, one of our really important machine learning models was our pricing model. Literally every dollar that flowed from our customers and into Convoy's bank account went through that model. There is almost nothing that is upstream that is more important than breaking that model. And so the business should have the right to say, I don't care what it is that you're doing. You need to make sure that the change, any breaking change does not happen at all. Like everybody needs to be on the same page, like the model owner and the data producer before a change happens. So that's one example. But maybe there's other things where that doesn't need to be the case, right? Like maybe I have a dashboard and I'm looking at, I'm tracking some event, some metric over time that's like a person has clicked a button in the app. And the thing that the producer is changing is actually really important because they're shipping a high impact feature and it needs to be out by next weekend. Well, in that case, it's actually not the worst thing in the world if, I have to do a little bit of effort on my side to backfill the data that's coming in. But I, as the consumer, should still be aware of what's about to happen. And the producer should still be aware that they're going to break me. And it should still be their responsibility to communicate those changes.
So what are the other elements of a data contract or the other things to make it work?
Yes. So what I just described is sort of the spec, right? The one part of the contract is the spec, which is the artifact that describes what the data actually is. The other part of the contract is you need a mechanism of validation and enforcement, because if it's just a spec sort of sitting in Git somewhere, that doesn't do anything. You actually need to have some way of telling people, hey, you're about to violate this contract, or you already have violated the contract. So to me, there's sort of two components there of enforcement. The first is prevention in CI, and then the second is detection after CI. Mm-hmm. So for prevention, what we did at Convoy is we would basically extract the schema from the contract and then store it in the Confluent Kafka schema registry. Mm-hmm. And then we had a set of checks that would run. We basically had a monitor that would run on any database that was under contract. And so if we detected a change being made, we would check the registry. We'd say, is this change backwards compatible or not? And if it is not, then there is some action that we could take. And that action could range from just breaking the build, or it could range from just having a GitHub bot comment on the PR with like relevant information. So that's sort of the CI stuff. But there's other things that are really important about the data that you can't catch that early. So an example might be, I always expect the distribution of a column to be normal. And if tomorrow it's a bimodal distribution, that probably means there is a bug introduced. It doesn't mean that the underlying universe has changed in some meaningful way. And those are the types of things that you're probably only going to be able to check, in your analytical database. And so you would need to have some set of monitors that is potentially running once per day. You could use Monte Carlo for this. There's a variety of other tools that kind of do this type of thing and they specialize in it. But what my proposal is that you don't need to be running that type of anomaly detection on top of the entire data warehouse 24/7. You only need to be running it on the pipelines that are really important to you that deserve a contract, right? And then there's everything in between. So really any piece of technology that facilitates moving data from one place to another, any sort of node in the graph, so to speak, you could potentially have either a mechanism of enforcement or a mechanism of prevention. And all of these constraints should essentially stem from the core contract, which is technology agnostic, right? So you're sort of inferring what are the technology specific constraints that need to exist based on this like central thing that has nothing really to do with tech at all.
Great. Wow, that was quite a great, almost like a lecture on data contracts in a nutshell. Thank you so much. What are the biggest lessons learned so far for you, or any advice you would give to data leaders on the topic of data contracts?
So the big piece of advice that I would say is, don't try to boil the ocean. Data contracts are exceptionally powerful, but they're not meant to be used everywhere. I think that you need to have two environments. One environment for doing fast iterative prototyping that lets a data scientist or analyst, pull raw data in, test it out, treat it like an MVP. But once they are confident that that particular data set is very useful to the company it's dating and it's making money, now is the time that you should apply the data contract. And in my mind, once it has a contract, that is what differentiates any old data asset from a data product, right? The data product is the data asset that now has ownership and clear API management and constraints and quality checks and things like that. So don't boil the ocean, stick to the things that are very useful. And the way that you know if something is useful or the way you know if a team has a useful a use case that could need a contract is to just listen to who's complaining the loudest about data quality. Usually the product teams that are the angriest that are saying like, hey, I need data engineering to go fix this pipeline like right now, tomorrow. It's typically because something is failing in a way that is potentially costing them, right? Maybe they have a KPI to make a certain amount of money in that quarter, and not having high quality is preventing them from doing that. That's probably something that would necessitate a contract.
Thank you so much, Chad. So you're calling in here from Seattle. That's really great to have your perspective here on data contracts at the Data Masterclass podcast. And I think it's really a hot topic at the moment. It's something we need to watch, because every one of us, because I think data contracts is something that will probably play a quite important role to fix out some of the fundamental issues that we created in the last years. To get data really working at scale for organizations. And for anyone who wants to follow Chad's work, you have a Substack channel, is that right?
That's right. It's just called Data Products. I think dataproducts.substack.com. Yep.
Perfect. Thank you so much for being with us.
Thank you. Thanks for having me.
Borek Data Masterclass, where great data journeys begin.